I'm going to start now a series of 3 sessions of 2 hours each. This is a session on solar DC powering residential and business sectors. Yes. This is a very different kind of 6-hour module, 3 sessions of 2 hours each. Today will be the first one. The first we'll do 5 hours of a lecture and then 1 hour of tutorial. What am I actually trying to do in this course? We are talking about DC power. We are talking, of course, solar. We are talking about DC power. DC power line at homes and offices. All of you know that the world over, the power line that is used at homes and offices is AC. In India, for example, 230 volt, 50 hertz AC line. What I'm saying is that we'll replace this with a DC voltage. Now, the first reaction of many people is that, are we really pushing the world backwards with DC power? This issue of DC used to be there somewhere in 19th century, 1880, 1870, 1890. The debate on AC and DC was going on, and I'll talk a little bit about it, and got settled by around 1895 or so, or even earlier. And from there onwards, what has developed is AC power. And suddenly, why am I talking about, therefore, DC power line? Remember that we are not talking about DC power line for transmission. Transmission can remain as it is on AC. What I am talking about within homes and offices, having a power line which is DC. What is the reason for this? The reason for this is that, for example, in India, we are suddenly seeing that there are homes which are starting to use DC power line. And Sasaram in Bihar, one of the city, may become the first city somewhere in the middle of this year to become fully DC. That means all homes may have DC. And what I'm saying, that this will be the first in the world to do that. In years to come, maybe 20 years, maybe 30 years, maybe 40 years. No, I don't think it will take 40 years. Maybe in 20 years, maybe in 30 years, maybe sooner. All over the world, what is likely to be that the homes will have DC power line. And immediately the question will come, what have I done? Am I going crazy? Is this really true? Why? Is this DC not pushing us back by a century? What has changed and why now? Suddenly in 2016 and 17, why have we started talking about DC? Before we answer the question, let us look at a little bit of history. What was going on? If you Google something called war of currents, you will get this page. There was a big war of currents. AC versus DC debate took place. Please go through. Very interesting debate. It was in late 1880s, somewhere 1887, 86, it started for several years. The war took place between 2 corporates, but 2 gentlemen were leading it. Please. One was Thomas Edison. All of us know about Thomas Edison. And Nikola Tesla. Actually, less of us know about Nikola Tesla. Though it will come out that Nikola Tesla won over Edison. Everybody thinks that Edison was father of all electricity. But you will find here that it is a Nikola Tesla which won. They are embracing a war which is now known as war of currents. Edison actually developed direct current as a standard in the United States in the early years of electricity. He was trying to push that. Tesla, on the other hand, betted on AC and was trying to push AC. Basically, the problem was that if you take a DC power, and at that time, converting DC power from one voltage to another voltage was difficult, particularly higher voltage. If you have 100 volt and if you want 200 volt, it was very difficult. It was not easy. And you see that for AC, it was very easy. And the importance of this changing of voltage, and what has changed since then is what we are going to discuss. Tesla believed that alternating current was a solution. Basically, one could easily convert from one voltage to another by using a transformer. So in fact, Nikola Tesla, he has number of patents. Of course, induction motor was acquired by Westinghouse, and later on Westinghouse took the lead in that. But essentially what he came across was this transformer. Now, therefore, if you started with 100 volt, converting in 200 volt or even 500 volt, all that it required is 1:5 transformer. And why was this conversion from one voltage to another important? And why did he win? So, for example, the DC voltage that was used by Edison in the beginning was 110 volt. Now, if you transmit 110 volt DC, on a copper wire, there are losses. And you cannot increase the thickness of the copper wire very much, because if you increase the thickness of the copper wire, the cost will go up. Thickness that they were using, and when that was used, within a kilometer, the loss was fairly significant. And therefore, one would say one will not be able to go more than a kilometer. So from a generator, one could power homes and offices within a kilometer. Otherwise, it will require rich, expensive copper wire, and nobody was willing to put that. On the other, it was felt that if the power is doubled from 100 to 200 volt, what will happen? The voltage was doubled. What will happen? If voltage was doubled to 200 volt, at the same power, the current will go down to half. If current goes down to half, what is going to happen is that the losses will go by a factor of 4. So instead of 1 kilometer, one will be able to go to 4 kilometers. In another way, what I am showing here, if power doubles at the same voltage, cross section needs to be increased by 4 times, because the losses were I square R. I have put it there as I2R. It's I square R. All of us know that. So essentially, if the more power was required, then even 1 kilometer range would have been difficult. On the other hand, if I could double the voltage, for the same power, I could go 4 kilometers without much difficulty. So this is where we had a very interesting thing, that William Stanley developed the first practical AC transformer for Westinghouse. Actually, it was a Hungarian team of 4 people who had actually developed this transformer. And all of us know about the transformer. Transformer is very easy to design. Now, AC transmit voltage could easily be increased by a transformer, stepped up and stepped down. So you can start with 110 volt AC, you can go up 200 volt AC or 400 volt AC by just a transformer. And then if you go higher voltage, like 400 volt, you will require 1/16 of the wire to carry the same current, because I square R comes. Or you can go maybe 4 times the distance and still have 1/4 the thickness of the wire. That will reduce the cost. Westinghouse took a patent in US for the Hungarian transformer and pushed for the AC line, and said, well, AC can be transmitted longer distance. You don't need to limit the generator to be within a kilometer of your home. It can be 20 kilometers, it can be 50 kilometers. You can go higher and higher voltage. You can go to maybe 1000 volt, in which case for the same power, the current will go down by a factor of 10, the losses will go down by a factor of 100. So, and therefore higher voltage transmission would start. This was what AC gave us. DC was very difficult. Transformation from one voltage to another was extremely difficult. So essentially AC won. This was a very bitter war. It will be very interesting for you to read, because it's actually a war between 2 corporates, not just 2 scientists, but 2 corporates. And just like many times when 2 corporates fight today, they use politicians and bureaucrats to side with one or the other. That was also being done commonly. And it was not a problem at all. So that is what was used. So, but finally, there was a clear reason why AC could be transmitted more easily rather than DC. Back in 1880s, and therefore AC won. From there onwards, AC development started, AC for long distance transmission, AC for power distribution grid, AC at homes and offices. Initially the appliances were DC, but one stopped using DC, because how do you convert AC to DC and all that at home, keep everything AC? lights came out AC, fans came out, motors, induction motor became very easy, the AC induction motor, fans, refrigerator, air conditioners, mixers, washing machine, displays, everything was using AC. From there onwards, AC was more and more perfected. As the wires reached more and more homes throughout the world, people started worrying, should you use 110 volt or use 230 volt, 220 volt? In Europe and in India, we started preferring 220 volt. Both were 100 volt, 10 volt and 220 volt. There was talk about what happens if there was a shock. In early days, number of people used to die with shocks. Over time, miniature circuit breaker was developed. You probably know that the miniature circuit breaker, within milliseconds of your touching a wire, shuts down the power and essentially has made the home wiring and office wiring very safe. On the other hand, very little development took place on DC because DC was not to be used. Not for homes, not for offices. Why do you use DC? If you're not using DC, why do research in DC? There were occasionally some work, but by and large, work on DC stopped. 1 century, the work focused on AC. And today, therefore, we have AC, AC, and AC. And therefore, when I sit here and say, let's move to DC, people would call me crazy. But I will show you towards the end of this course that it makes huge sense. In the beginning of 20th century, diffusion of technology and innovation highly depended on market as well as government policies in regulating the market. In fact, that is so today also. Technology and innovation diffusion depends on the market as well as the government policies. And government order objective to conversion from DC to AC found that calculation shows that AC fan consumed twice as much power as DC fan. Now, this took place in the beginning of around 1910. Even in India, I have seen in archives, there was a big government question that why convert DC to AC? Because if you do use DC fan, it will consume much lower current, much lower power. The whole focus on AC was so strong because of transmission. All this was sort of saying, okay, let there be a little bit of energy loss, let's move to AC. Government also feared, there was then some talk about mixing AC and DC. But the government feared that mixing AC of DC would produce endless trouble and inconvenience to consumers and the owners of the buildings, which electric apparatus are installed. And therefore, that was also given up. Now I'm going to talk about all these things today. Continue on DC, have a mixed AC to DC. Why? Because all this took place around 1900, 1910, 1920. Since then, lots of things have changed. Even as late as middle of 20th century, some remnants of DC power was there, but they all disappeared. And one would thought that DC is dead. And this is one thing that you will learn if you are a scientist and technologist, that in technology, nothing dies. It goes a little bit underground, simmers there. Someday, suddenly it becomes extremely useful and comes out. And this is what has happened to DC. It became suddenly very useful, and today it is coming out stronger than ever before. Late in 20th century, however, in last 20 years, 25 years, 30 years, when DC was declared dead, DC suddenly starts waking up. It starts creeping in. That's what I'm pointing out. Slowly. For example, the first thing that came was a high voltage direct current HVDC electric power transmission line. Now this is very funny because the reason DC was defeated was it could not be transmitted long distances, and HVDC has come in because it is better to use direct current when you do high voltage and long distance transmission for very large amount of power. For example, today in India, there is a link between Nepal and Delhi. That is a HVDC line. In fact, all long distance links are today very long distance links are increasingly moving towards HVDC. Why? Suddenly, one actually found that DC was less expensive and lower electrical losses. Why? Basically, there is this something called skin effect. AC at high voltage tend to get transmitted more and more on the outside core of the conductor and do not use the whole conductor. If it does not use the whole conductor, what happens? The copper that it sees is less and therefore resistance is more. DC on the other hand is transmitted throughout the conductor and therefore sees whole of copper and the losses are less. Now this was realized, and once this was realized, long distance, particularly long distance losses can be high. One started using it. Similarly for underwater power cables, avoids heavy currents to charge discharge of cable capacitance each cycle. Each 50 hertz, 50 times in every second, there will be charging or discharging. The water is, after all, I know it's a poor conductor, but it is not zero conductor. Even for shortest distance, the higher cost of DC conversion equipment may still be warranted to benefits of direct current length. Now, these talks have started in 70s and 80s, 1970s and 80s. Remember that in 1970s and 80s, electronics have started developing and power electronics have started developing. As power electronics starts developing, the conversion of DC from one voltage to another voltage, which was looked almost very difficult in 19th century, in 1890s, was no longer particularly, as opposed to having higher losses in DC transmission line, might as well go and do the conversion. It is the power electronics that started coming. It also means that power transmission in unsynchronized transmission systems. So there can be one system. The grid need not be a single grid all over the country. If you use a grid all over the country, something happens and grid goes down in one part of the country, the whole country becomes dark. Many of you may remember that about 4 or 5 years back or so, there was a complete shutdown of the North Indian grid. The whole North India had gone for a toss. This is a single grid. Today people are sort of saying, if you isolate these grids and connect them using DC transmission line, and therefore there is a conversion from there, even if something goes down, only that part of the grid will go down, whole country will not go down. So for a variety of reasons, the high voltage DC transmission lines have started coming in. In fact, another very interesting thing that is being talked about, between countries, people are sort of saying it may be worthwhile doing high voltage DC transmission line. Now, if you remember that now solar power is becoming very, and this talk is on solar power, very inexpensive and very common. But the only thing is solar power is available only in the daytime. So 5:30 in the evening, India will not have any power. But you know, Pakistan has a power till 6:30 because they are 1 hour beyond us. And maybe Iran have a power 2 hours. Maybe the Saudi Arabia may have a power even 3 hours later on because they are 3 hours beyond us. So even if it is 8:30, it is here, it is 5:30 there, and they may still have power. And maybe if you go further west, they will have power even later in the evening. If everybody starts generating and start transmitting power to the east, then the solar can be there all the time. And this is possible only most cost effective only if you use high voltage DC transmission line. So DC transmission line, high voltage DC transmission line is common. Nobody will question you today. In fact, that is taught. But if you talk about DC in low voltage and low power at homes, you'll be called crazy. And that's where let me come in. But you know what we have forgotten, that till around 80s there was not much electronics at home. There used to be this odd transistor radio or a radio. That used to be electronics with vacuum tubes and things like that. But there was not that much. But since then in your life, electronics dominate. At home, you have television, set-top box, you may have a router, you may have a modem, you may have a laptop, a computer, a cell phone, a micro speaker system, music system, all are electronic systems. All this is there everywhere. And what is happening? This in late 80s, electronics entered and started dominating. Till 80s, it was expensive and less reliable. But what happened? Essentially, integrated circuits came in 70s. What did integrated circuits came in? That instead of having, for example, we used to build a transistor radio with about 65 components, and suddenly you could actually build it using a single chip. You could put all that components into a single integrated circuits. Very small size, very low material consumption, And they are not multiple components joined together. They are joined at the time of designing. So nothing goes wrong. No interconnect goes for a toss. So it becomes far more reliable. And then he tried some Moore's law. Essentially, if I can use better photolithography and can print that electronics in smaller and smaller size, I can use less and less material. So the cost goes down, the size goes down, power consumption goes down. All of you have known about Moore's law. Every 18 months, all these things goes down by a factor of 2. So also very important came programmable processors. One could integrate. So programmable processors and circuits leveraged integrated circuits. So software became way of designing things. You can write a software, and that software you can put on the same hardware different software, and you can have therefore different design. So that became very important, and of course Indian engineering talent leveraged that carefully. Electronics permeates every aspect of life: cell phone, TV, computers, sensors, everything. In offices you'll use started sensors, but all of us very often do not think about it. All electronics is DC powered. There is no AC electronics. In fact, it's a low voltage. It used to be 24 volts, 12 volts. Now it is 5 volt, 3.6 volt, 2.9 volt, 2.3 volt, 1.8 volt. All electronics, DC. What does it mean? I have this laptop, and this laptop is connected to AC power because my power line is AC. I use an adapter. Can you see the adapter there? This adapter, for example, is a AC to DC converter. The television has a AC to DC converter built in. The set-top box has a AC to DC converter. The cell phone has a AC to DC converter. Well, cell phone charger has a AC to DC converter. So everything has a AC to DC converter. In fact, nowadays lights are LED lights. When you use LED lights and it is connected to 230 volt AC, every LED light has a AC to DC converter. Each AC to DC converter adds losses, adds cost. We'll talk about these losses, and impacts reliability, become more and more unreliable because these AC to DC converter are more likely to fail than the rest of the things. And yet, therefore, all over there is electronics, and all over we are using AC to DC converter. Well, as I pointed out, LED lighting came a few years back, almost 2.5 times more energy efficient than CFL, and slowly replacing CFL. You know about the India's LED program, and we are now putting about almost 10 lakhs LED bulbs every day. We have reached in crores. At one time price was higher, but the price is therefore dropping like anything. And LED's life is much more, 8 to 9 years, as opposed to 12 to 18 months for a CFL. It's available in sellers. So one started using the LED, but LED is DC. That means every LED light has an AC to DC converter. Adds cost, impacts reliability, and adds losses. So why do we continue to use that? Displays. At one time, displays were CRTs, and when there were CRTs, high voltage and power required to drive it. It used to be AC, plasma display, better quality. All these were there, but today all these have become old. Today you have LCD display or LED display. Once again, only uses a DC power. So you see, DC is coming into our homes, whether we like it or not. Of course, they are all using AC power line. So everywhere there is a converter. And each such appliance, one has a AC to DC converter. Converter have losses and cost and are mostly less reliable as compared to the rest of the system. Poor quality converters could impact power factor also. That's another very big problem, because in AC there is a power factor issue. If the voltages and the currents are not aligned, you will get into trouble. So essentially, all these converters are starting to cost. One is sort of thinking, can we have a DC power line? But so of course, it's a major step, and therefore it would still not have happened. And therefore, it has not happened as yet, though there is a lot of talk about it. But bigger things were still to come, especially like India, and it has to wait till this decade. India uses 72% of its domestic power in lights and fans, particularly in poorer homes. Mostly it's lights and fans, a little bit of electronics, maybe a television. If you take lights, fan and television, it will probably 90%. So if we are doing that, and lights, fans and television all are DC. Fans, I'll come to why is it DC. Should we go into DC? This is the question that we started asking. The question was, a ceiling fan is a lifesaver in a hot country like ours. all homes have these ceiling fans. These ceiling fans were designed long time back. I remember I talked to you, there was some debate about AC versus DC, but finally AC induction motor fan is what is used. Very simple to design AC induction motor. The moving part does not have any current passing. So there is no slip and there is nothing, otherwise cables will keep on moving. So those kind of earlier rings were used. None of those things will require, because only the stator, the stationary part, will require current. This is what the induction motor was. The induction motor fan, the one that we use at our home, all of you use, would consume 72 watts. And versus when you reduce the power for that and try to rotate it slowly, still does not consume so much less. It consumes about 60 watts. Because essentially you start burning the power. You are essentially doing resistance. Of course, some of them are using other things like some electronics is occasionally used, some other things are used. So you can reduce power. By and large, power is wasted as speed reduced. So first of all, use 72 watts and power is wasted as speed reduced. Now comes a very interesting thing, brushless DC motor. Now remember, the DC motor used to exist, but the DC motor that used to exist used to be with brushes, because the brushes will connect the rotating part, transmit the current between the rotating part and the stationary part. So these brushes will rotate, and brushes will be able to rotate. They will also be able to conduct. And the brushes used to wear off. I remember seeing DC fans when I was very, very young, around 1960. And every 8-9 months, you used to bring down these fans, and there used to be this black soot coated brushes which had to be taken out and repaired. New ones had to be put in, otherwise it will not work. But suddenly you have this brushless DC. What has made this happen? I'll talk about it. It is the power electronics which has made this happen. Power electronics integrated circuits. Power electronics was there at that time. One could make power electronics brushless DC motor, except it should have been expensive. But the important thing is the brushless DC motor fan, equivalent fan, exactly the same fan, will only consume 30 watts. But it's also driven by DC. Brushless DC motors at least have a magnet. You have the switched reluctance motors, which does not even have a magnet. More or less performs the same as brushless DC and also is using DC. So this we'll talk more about it. As I told you, brushless DC motor was not new. It was known, was always known, far more energy convenient. You could do very good speed control. When you reduce the speed, for example, from 30 watts, you reduce the speed to minimum, you will consume only 9 watts. So extremely good. It used power electronics. But why are they getting in fans today? The power electronics used to be very, very expensive and unreliable. Just like electronics used to be very, very expensive. Remember, I told you till around 80, electronics did not come to the life. Because electronics was there, but it was very expensive. Because there used to be discrete components. A transistor used to have 60 components and you had to solder them together. Integrated circuits came in, it became reliable, less expensive, riding on Moore's law. Electronics came in. But power electronics, what became integrated circuit was low power electronics, very low power electronics. In fact, the power kept on going down. Voltage kept on going down, power kept on going down. The higher power electronics, even anything which will move a motor or even a switch would require power electronics. And power electronics remained discrete because nobody knew how to make power electronics integrated circuit. Change happened in the middle of the century. In fact, many of the Indians participated quite a bit of it. Indian researchers in the United States. In fact, 2 of the alumni of IIT Madras, Jayant Baliga and Krishna Chenoy, led this whole thing. But there were many others from different IITs and different places who actually started working on power electronics integrated circuit. Whether it was MOSFET or IGBT or variety of things, and you can put the whole thing into integrated circuit. Those integrated circuit ICs started coming around 2004-05 and only now have become popular, and they are behaving exactly like the low power electronics integrated circuits. They integrate all the circuit into single chip. The cost is low, it is very reliable, and cost keeps on going down year after year. Power electronics integrated circuits came in and have become meaningful in only last 3 to 4 years, 5 years. Low cost. And that is what has made brushless DC motors and SR motors possible today. So the last citadel of AC at homes, the motor, which is used in fans, which is used in a mixer, which is used in a refrigerator, which is used in a washing machine, which is used in air conditioner, is becoming DC. Everything is becoming DC. There is nothing that is left. So power electronics integrated circuits came in, and Moore's law, high current and voltages can be switched thousands of times. In fact, one of the most interesting thing when I learned about power electronics, and I did not that, when you used to make a converter, AC to DC converter, we used to have a transformer at the front end. Basically, a transformer required, but this used to be a 50 hertz transformer, because AC was 50 hertz, the transformer was 50 hertz, because the 50 hertz, the varying current will induce magnetism, and from one part to another it will get induced, and that used to be captured. Once you started switching it not 50 times but 500 times, what will happen? As you switch it 500 times, the magnetism will increase by 10 times. If you switch by 5,000 times, magnetism can increase by 100 times. So you don't need this bigger transformer. You can make it very small. You don't need so many turns. In fact, by using 1,000 times, even 6 turns may be enough to make a transformer. Suddenly, this micro transformers, magnetics, what is known today, became very important. Magnetics is extremely important. Making the right transformer, miniature, running not at 50 hertz, running at 500 hertz, running at 2000 hertz, running at 10,000 hertz. And they are very, very small size. They are very less expensive because they use very little material, much more reliable. And along with power electronics and this miniature transformers, magnetics, which became possible because of high frequency switching, which was possible because of power electronics. All these brushless DC motor, switch reluctance motor, variable frequency drives are a result of this revolution. And all of them are sort of saying, now, no need for AC, move to DC, move to DC, move to DC. The DC motor, base ceiling fans can only 40% of power as compared to the AC induction motor. And BLCC motor are DC power driven. An AC to DC converter is required if you use the AC power line. Why have that? Why not have a DC power line? Refrigerator similarly consumes is primarily motor, air conditioner is motor, mixer, washing machine, grinders are all motor. All of them will have brushless DC motors or switched reluctance motors in future. In fact, today they're already having it. All of them unnecessarily have AC to DC converter. So you have AC to DC converter in everything. Every sensor, you put a temperature sensor, you use a proximity sensor. When you put your hand next to a tap, the tap opens, you are using some sensor. All of them are DC, and every one of them has AC to DC. In fact, I went into a bathroom fitting recently, not very large bathroom. Some 10, 12, 15 people could use it at a time. And we counted, there were something like 60 AC to DC converters. And then one will say, why have all this? There's a strong case for DC power line to drive the DC powered devices of the present and the future. All the sensors are DC. AC appliances will slowly fade away. No need to have AC to DC converter. But not just this, there is more. And this course is going to talk quite a bit about that. There is what is called solar photovoltaic panel. Rooftop, you can put it. Cost of that has been going down so dramatically. Many of you have heard that recent bid of solar in India. The bid came to 2 rupees 90 paise per 96 paise per unit of power for next 25 years. So solar PV only produces DC power. If rooftop solar is used at home, then an AC to DC converter is needed. That will have a losses. Then along with solar PV, you always use battery because solar power will fluctuate. It's not constant. And the battery only stores DC power. It's charged by DC power. It gives out DC power. So you'll require AC to DC converter to charge. You'll require a DC to AC converter to discharge. And one of the most dramatic thing that happened is that about 4 years back when I started working on this, and I said, well, let's take a small rooftop solar, 125 watt, 150 watt. One found that the converter losses are 15%. AC to DC converter and DC to AC converter. I said, why? Why don't we make better converter? Some of the people in my team who knew power electronics and I did not said, no, sir, if you make it, it will be very expensive. Not possible. I said, no, you people don't know. You have to make it. And he came back saying, well, we can make it. If you are willing to pay 4 times more price, we will be able to make it. Instead of 15%, maybe 10%. I said, but 10% is also bad. Every converter. And if you remember, you have to put 4 converters, it is 40%. And if you do 15% each, it's 60%. But they say, and the cost will go up like anything. You just cannot do much more. Otherwise, you will not do power factor correction. People say, well, I say power factor correction, if you don't do it, will hurt the power lines for the transmission. So therefore, we said with DC power line at home, everything can be together. Why can't we move to DC? DC power line at homes and offices therefore came in. Future appears to be there. Huge power savings. Legacy and our mindset. Saying 2 mindset. 1, the war has been won in 1890s. A lot of things that you used to do in 1890s you don't do today. Why are you stuck there? The second, but has any other country done? But why should you always be a follower? Why can't we do it before others do it? Next question, why doesn't the West do it? Why doesn't US do that? US is considered ahead of everything. Well, they've already connected all homes. They're not putting new lines. They have sufficient power. Everything's working well. They will be less reluctant to make changes. In India, there is power shortage. The number of new homes, the new buildings that we build in next 15 years will be much as we have today. Why should we always be a follower? As our Prime Minister has been saying, do we have guts to lead? Maybe in the phase we can have dual lines. A DC power line and an AC power line. And immediately people say, no, sir, but that will cause problem. And then I point out, do you know your home has 2 power lines? One is a 5 ampere line and another is 15 ampere line. The 2 are not connected and you should never connect them. 5 ampere line and 15 ampere line. 5 ampere line is for your lights and fans and maybe your television and laptops and cell phone charger. 15 amperes line is for your air conditioner and for your grinder and for your microwave oven and for your heater, refrigerator. Just say that let the 5 ampere line become a DC line and 15 ampere line for the time being be AC line. The thing is, we are reluctant to change. We are reluctant to take a risk, and you can never get ahead in life. A country can never go ahead without taking risk. This is what I am going to do in this course. Tell you how to take risk. Not just tell you how to take risk. We have taken risk. We have built. Today, we have 10,000 homes connected on solar DC in the country. There is an article in IEEE Spectrum magazine of February 2017. Please take a look at it. February 2017 on how we have done. And to our great surprise, 3 days back, IEEE United States, IEEE Spectrum declared the solar DC technology to be 2017 Technology of the Year in the service of society. It has acquired probably the highest accolades that technology has ever acquired. Simply because we have dared to go away from the past. And what I'm going to do in the rest of the course, tell you how did you do it, a little bit of computation, and then urge you that let us not just support solar DC, but move to build solar DC systems. You are all electrical engineers, maybe many of you are power engineers. There is a lot to do. Let us take them in the world. I think I'll stop here for a first lecture with a short question in class quiz. At AC voltage, at low voltage, which one is true? AC requires protection, DC require protection, AC doesn't require protection, DC doesn't require protection. What is the correct answer? In fact, I've not talked about it, but we will talk about it later on, but I still want to throw this question so that it makes you thinking. And the second question is, most of the electronics are AC powered, DC powered, both and none. The second is very simple. Tell me the answer for the second first. Second question is very simple. I have BEC Suresh in front of me. The answers are A, AC powered, B, DC powered, C, both, and D, none. Can you give me the answer? How many of you think A is the right answer? Raise hand if you think A is the right answer. BC Suresh. How many of you think B is the right answer? Raise hand if you think B is the right answer. I see one hand. Oh, I see 3, 4, 5. Everyone is now raising hand. How many of you see C is the right answer? C is the right answer. Both are not electronics, and D is none. Of course, that is not a sole answer. You are right. B is the right answer. Most of the electronics are DC powered. Question number 1. At low voltage, AC requires protection, DC requires protection. AC doesn't require protection, DC doesn't require protection. The question should be at what low voltage? For example, let us say 20 volts. What do you think? Does AC require protection? Does DC require protection? Or do you think AC doesn't require protection, DC doesn't require protection? Can you raise hand? How many of you think at 20 volt AC requires protection? BZ Suresh. B, does DC require protection at 20 volt? C, will AC does not require protection. AC does not require protection. DC does not require protection. None of you are answering. Yeah, that at least people have answered. Yes. Actually, at 20 volt, neither AC nor DC will require protection. At 100 volt or 75 volt, both will require protection. And we will deal with it. At 60 volt and below, does not require protection. But again, DC can go around that. AC, small change, but below 60 volt, basically protection is not required. So I think I'll stop here for the first this. And if you have questions, I'll answer the question. You can raise questions and we can answer. Then we'll go to. Anybody has questions? If you don't have questions, I'm going to ask questions. I'm seeing this college. BC Suresh. Yeah. I have a person with a specs with a t-shirt. The third person, specs with a t-shirt. Yes, can you stand up? Specs with the colored spec t-shirt. It is a reddish red t-shirt with green stripe. Can you get up, please? Yes, get up. Yes. What is your name? Can you say something? Vipul? Vipul. Do you use LED lights at your home?
No, sir.
Have you seen LED lights anywhere?
Yes, sir.
Do you know the LED light only use DC?
Sir. Do you know that LED light uses DC? Yes, sir.
LED light only use DC.
Yes, sir. Yes, sir.
Yes, sir. You knew it. What does it mean when you connect it to the 230 volt? How will you connect it to 230 volt? The LED light.
There will be a circuit in that bulb.
What kind of circuits will be there?
Rectifier for AC to DC.
Yes, it will be AC to DC converter. And that AC to DC converter will mean losses, etc., etc. We have a question: how can we improve distortion factor? Distortion factor in where what? I don't understand. You are talking about in AC. How can we improve distortion factor? You must be meaning how can we improve power factor? Well, there are circuits today. When you do AC to DC converter, you can design the circuit that the power factor is nearly 1. If you don't do that, then it will become. Yes, you have a question, please. Please.
Sir,
Yes.
good morning, sir.
Yes. Your name, please.
Sir, I have a question. Like you said already that DC current is easy to transfer for long distance. Is it possible to transfer for short distance, or how can we do this?
Even for shorter distance, technologies are developing. You can convert DC to higher voltage and transmit. But as of now, in distribution, it has not been used. Tomorrow it may be used, you don't know, because it is known to have less losses. But what we are talking in this course is using DC only within homes and within offices. So we are not talking about DC transmission. Long distance transmission, it is used, Distribution, as of now, it is not used. There are some microgrids which are trying to do 380 volt DC distribution, but very minimal. In future, this may be transmitted, done.
Okay.
Yes, somebody else has a question? I see, yes.
Hello, good morning, sir.
Yes.
सर हमारे पास जो गांव में आटा पीसने की मशीन है और उसके लिए हमारा 2.5 HP का मोटर लगाते हैं हम उसको, एसी से चलता है। अगर हम उसको डीसी पे रिप्लेस करना चाहिए तो उसके लिए हमें क्या करना होगा, मतलब कौन सा बुशलेस मोटर या एसआर मोटर कौन सा सर सही रहेगा, क्या उसमें रिक्वायरमेंट रहेगी?
Okay. Question is, there is a atta chakki, grinding of wheat, wheat grinder, and it is, you are using it at your home. What is the power consumed there? Tell me the power consumed.
2.5 HP.
2.5 power. Very interesting. I think if you do it right with SR motor, you will be able to reduce by a factor of 2.5. So you will be able to do it with 1 horsepower. In fact, we are developing a atta chakki, a smaller atta chakki. Will be in about 3-4 months time. We will probably have that atta chakki. It will reduce the power consumed by a factor of 2.5. But of course, you have to develop the right switched reluctance motor and then power it using D. You will be developing it. We have developed a mixer. A typical mixer consumes about 350. AC mixer consumes about 350 watts peak, 350, 400 watts peak. What we have developed consumes only 150 watts. If you ever come to IIT Madras, you should see that. Of course, soon you will see many more of those things in the market.
And next question.
Thank you. Thank you. Go ahead.
सर जो चारा काटने की मशीन होती है, ग्रास कटर मशीन होती है सर, उसमें जो लोड लगाते हैं हम वेरी करता रहता है, तो उसमें कौन सा मोटर यूज कर सकते हैं? जो आटा मशीन होती है उसमें तो कंटिन्यूअसली चलता रहता है।
वेरी क्वेश्चन. दिस इज द चारा काटने की, द ग्रास कटर मशीन, and you are saying that also is using AC according to you. Study that. What is the power consumed for that? Send me. You have my email, Ashok, ASHOK. I'll write it down. My email is ashok@tenet.res.in. Also put the question in the course pack. There is a and please note this email ID. Send me a email on that chara katne ki chakki, chara katne ki machine, that grass cutter. What is the horsepower used? It will be a very good project to develop. Try to do a DC motor. In fact, your college, you can take it up. Develop a appropriate switched reluctance motor for doing this. We can help you. I'll also try to work on this in future. Excellent question. Which college are you?
Deenbandhu Choturam University, Murthal, Sonipat.
Sonipat. Thank you very much. I'm now going to start the second lecture, powering residential and business sectors, L2. We will be looking at first appliances, and after appliances, the next lecture is going to focus on appliances. Having seen the case for DC power line at homes, let us look at appliances. Appliances, motors and recent trends, use of direct current replacing AC power, efficiencies available and costs. So let me roughly go through that and then get into the solar. For example, most of you know that TVs have been changed. It used to be the all CRT TVs for long times, various shapes and size. But in last 10 years, it is gradually becoming electronics. LED, LCD, much larger resolution, much lower power consumption, all electronics much more reliable. This is the change that has taken place. So display technology has changed, and now it used to be plasma also in between, and today LCD and LED televisions are all using DC power, and all of you know, so they all are DC power. When you buy a television, it is a DC power television. Only thing is, it is designed with an internal AC to DC converter, and you therefore connect it to AC. Many of these television also has a DC input. Today it is not used, but you can use that DC input. In fact, when you buy tomorrow a television, you should look for that DC input. DC input does not cost more. In fact, it costs less. Tomorrow, if you remove the AC input, the AC to DC converter will go away. I was talking to one of the large Japanese company which supplies televisions, and it says that in Indian market, 93% of their failures take place in that AC to DC converter, because the power in India fluctuates quite a bit, and that's what happens. If you get rid of AC to DC converter and directly put DC, many of your problems will be solved. So we are talking about DC powered televisions. Cost is going to come down rather than AC. 40% less power consumption, 30% less cost. LEDs are DC powered. And of course, if you make it DC powered, it will be even costlier less. It will save you some. Lighting has changed from 60 watts, 32 watts, a bulb, 11 watt, it has become 5 watt, giving same lumens, and lifespan is much, much higher. It used to be expensive, the LED bulb and LED lights, but the prices have come down like anything. Today, LED bulbs are available at 50 to 60 rupees, 70 rupees, and the life is 8-9 years as opposed to 1 to 2 years. But remember, all of them has a AC to DC converter. If you remove the AC to DC converter, cost will come down further. Microwave oven. There used to be a huge microwave oven, 3000 watts in 1947, 900 watt microwave oven in 2000. It has become even sleeker. Now, one sort of said that, well, this at least will be using only AC. Not true. Inside, the AC is first converted to DC. DC is then converted to very high frequency, microwave frequency generator that cannot be run directly by AC. It can only run by DC. So essentially, a microwave oven would like to have a DC. Of course, it's a higher power, so higher power DC. So what is common in advancing appliances? Reducing power consumption, reduce size, ease of use, reduce cost, but most important, all moving from AC to DC. LED lights, TVs, microwaves, all are DC. And of course, electronics, laptops, mobile phones, computers, speakers are anyway DC. So we are not talking about AC at all. The question came motored load. I did talk in the last lecture a little bit about motorized load, but I'll talk a little bit more in this lecture. What are the motorized loads? Common ones are fans, air conditioner, washing machines, water pumps, mixer, grinders at home. And of course, our friend from Sonepat was talking about atta chakki, was talking about a grass cutter. All those are also motorized loads. What is happening in these motorized loads? The energy consumption efficiency of these appliances depend on the type of motor used. And historically, what was known was DC motor, what is called permanent magnet DC motor. Other based on stator and rotor configuration, where the important thing is the rotor. If you are going to put power in the rotor, if you put any coils in the rotor, then you have to use brushes. Historically, that's what used. A permanent magnet, if you use a permanent magnet in a rotor and in stator you push winding, then you don't need brushes. AC motors were both synchronous and induction motor came in. Induction motor became very, very popular, very easy to design, low cost. Only the stator needs coil and current. Rotor does not need a magnet, does not need a coils. Does not need a magnet, therefore cost can come down. Does not need a coil, so brushes are not required. So it works with induced current, induction motor. There are of course these new ones, brushless DC motor, switched reluctance motor, stepper motor, universal motor. We'll talk about brushless DC and SR motor a little bit more. The principle is create magnetic field which opposes each other. So either you have to have a permanent magnet, another one you create by using coils. Use two sets of coils and use do it. Stator is always stationary, rotor is always rotating. Both stator as well as rotor could either be permanent magnet or electromagnet. If rotor is an electromagnet fed by external DC voltage, it would need DC voltage, it would need brushes. Brushes have maintenance issues. That was the historical issues. AC was always running at 50 Hertz because AC was available at 50 Hertz. So every 50 Hertz, 50 times per second, it reverses polarity. Motor designed to rotate at fixed speed could be simple, will not require brushes. That is what the AC induction motor came. AC induction motor could be a three-phase motor, essentially runs very well at fixed speed, gives you very good efficiency, very easy to design. very low cost. Three-phase winding circuit on a stator with offset electric angle of 120 degrees connected to three-phase AC source. So one by one, the magnet will get excited and the stator and the rotor will rotate. Establish a rotating magnetic field which rotates at a synchronous speed. And I have given you something which your professors and motors will be able to teach you much more. What happened with power electronics and particularly power electronics integrated circuits? Earlier my AC bearing current, AC current always meant 50 Hertz. With power electronics, I can switch. I can start with a DC. Power electronics always starts with a DC power and then you can switch. As you switch, you create waveform. You can switch, of course, at 50 Hertz. You can switch at 1000 Hertz. You can switch, make one pulse smaller like this and another pulse bigger, then smaller, bigger, bigger, smaller. You can create as many different streams. The ability to create these pulses are very important. And pulses can be different width, can be of different frequency. And if you use this on a coil which is wound, you will create magnetic field. So you are starting to control field and not control magnetic field in a strict 50 Hertz, 50 times per second, every 20 millisecond. But you can control it at whatever speed, but also you can control magnetic field more at one time, less at one time. You can do whatever you want. Start with DC power signals. If AC alone is available, convert it to DC. Create multiple signal, 3 to 6, and put it in 3 to 6 different coils. And if you put it in 3 to 6 different coils, you are creating 3 to 6 different magnetic field, which is under your control. And now suddenly you are working with magnetics of your own. And let the magnetics move, interact with each other. They will tend to push, and you will create new kinds of motors. Brushless DC motor was one thing where a permanent magnet was used in the rotor. But no, I think a permanent magnet was used, but also the currents of the thing were controlled, and therefore you can run it at any speed that you want. You don't need 50 Hertz. You can run at any speed that you want, and you can make it extremely efficient. All this was difficult without the power electronics, but with power electronics integrated circuits coming in, it became very, very. The only problem is limitation of permanent magnet. And the permanent magnet, the material, essentially 90% of that material is in China. So we are going to be dependent on China. That is the only concern that we have. Switched reluctance motor, just see the kind of thing. If you see the rotor, that funny kind of rotor, 4 poles, it doesn't have, it is not made of magnet. It is just a steel material. And you have in this particular picture 6 different set of coils. And you can excite it any way you want. If you excite it in the right manner, you can induce the magnetic field certain manner, and you can keep on varying the magnetic field of the of the stator in such a manner that the central piece, the rotor, starts rotating. You can switch, and that is the switched reluctance motor. No permanent magnet required. Have a torque and ripple noise. So initially there was, when you're moving from one place to another, it was torque and ripple noise. It used to also make sound. But better and better signal processing, digital signal processing can be used to better control the magnets. And as you control the magnets better, you are able to do a smooth handover of the magnetic field, and things can start rotating smooth. There's a lot of work that needs to be done, a lot of interesting paper. But basically, people who understand digital signal processing needs to get it. And you, just like you use DSP to control a modem, to shape the signals of a modem, you are starting to do that for a motor drive. As I pointed out, since China has 90% of rare earth materials, it could control the prices for a BLDC motor, not for a switched reluctance motor. Switched reluctance motor, the steel is made in SAIL and by many other companies in India, and the coils are ordinary coils available, made by huge number of people. Key thing is to design and make plenty of it. So the new generation motors have far higher efficiencies, but need DC power to begin with, also called DC powered motors. If I compare induction motor, brushless DC motor, the induction motor speed control is not as smooth as it is in the BLDC motor. BLDC provides excellent speed control for acceleration and deceleration. You can do what you want. Induction motor, of course, is low cost. BLDC motor cost could low with volumes. Problem is the magnet. Magnet makes it high. Power factor and efficiency is poor at low speed for induction motor. In BLDC motor, you can get 92, 93 or even better efficiency. If I use induction motor and if I use solar, then I have to convert the solar power, which is DC, into AC. In a brushless DC motor, I can directly use solar DC. Induction motor does not act as a generator. Brushless DC motor, when it rotates in a reverse manner, it uses what's called regenerative braking. So you can regenerate the power. When you're braking, the power can be converted. It can be converted back into power, and that power can be used to charge the battery. So if you're consuming power from the battery, but when you're, for example, you are running a motor, you are running a vehicle, you are charging from the battery, you are taking the power from the battery. But when you accelerate or when you're running, when you decelerate, when you apply a brake, that deceleration causes regenerative, and it in fact charges the battery. You don't lose the power as much. In fact, you can get back most of the power. So good DC motors, regenerative braking is very, very important. It reduces the amount of power. The speed control of AC motor can be done. There is a device now very common called variable frequency device. Again, came into the picture along with power electronics integrated circuit. What do? You take 50 Hertz AC, you convert it to a DC, and then you use some kind of oscillator to make it oscillate at any frequency that you want. So you can make it at 30 Hertz, 35 Hertz, 25 Hertz, 20 Hertz, 60 Hertz, 65 Hertz. This is called variable frequency drive. And now variable frequency drive have started being used with a motor, induction motor, and it increases efficiency significantly. Because now you can run it at different frequencies, and at each frequency, the motor runs efficiently at some speed. You can do controlling of power factors. You are going to convert to DC. At that time, you can do power factor corrections. Application, therefore, you are using AC induction motor wherever DC motors are not available. With electric vehicle, air conditioning system, most industrial machinery, lifts and pump. In fact, I found the recent lifts all have variable frequency drives and pumps. Domestic appliances, fans, coolers, etc. So variable frequency drive is an alternative, but that also is powered by DC. AC is converted to DC and then it is powered by this. So variable frequency drive 50 Hertz utility into DC, then converts it into a variable frequency, and that gives you, by switching the inverter device on and off many times per cycle, a pseudo sinusoidal current waveform generated at desired frequency. Efficiency can improve at lower speed. This is what it is done. Summarizing the move towards DC appliances. All homes and office appliances are shifting to DC technology. It brings in huge efficiency, integrates well with DC electronics, becomes smarter and smaller. And remember, I had talked about solar is DC, battery is DC. What if you convert everything and use that into DC? These DC appliances need an AC to DC converter. If powered by AC, it's cost plus additional power plus point of failure plus power factor problem. But strong case for using DC microgrid at homes and offices. Easier integration of renewable energy sources, as all powers are DC power sources. Easier integration of power storage. Well, this is my second lecture. The question that I'm going to ask, first question, which among these appliances run on motor? Air conditioner, fan, TV, and inverter. Air conditioner is 1, fan is 2, TV is 3, 4 is inverter. Which of them run on a motor? The first answer is 1 and 2. Second answer is 2. That is air conditioner and fan. Second answer B is the 2 and 3, which is fan and TV. C is 3 and 4, TV and inverter. D is 1 and 4, which is air conditioner and inverter. Please look at the question. Please raise hand. How many of A is the right answer? Air conditioner and fan runs on motor. All of you have raised hands. B is the right answer. Which is 2 and 3, fan and TV. Nobody. C is the right answer, which is 3 and 4, which is TV and inverter. Nobody. And D, air conditioner and inverter. 1 and 4? Nobody. So the answer is right. In fact, air conditioner and fan runs on the motor, obviously. Question number 2 to the same college. Which motors among these have highest efficiency? Permanent magnet DC motor, single phase induction motor, BLDC motor, 3-phase induction motor. Highest efficiency: permanent magnet DC motor, single phase induction motor, 3-phase induction motor, and brushless DC motor. So please raise your hand. First I will ask with 3-phase induction motor, D. Is that the highest efficiency? C. Brushless DC motor. Is that the highest efficiency? Yeah, one by one everybody is raising hand. Single phase induction motor. Is that the highest efficiency? And permanent magnet DC motor. Actually, permanent magnet DC motor will be very close to BLDC. So the answers are yes. Right answer is C, brushless DC motor. But permanent magnet DC motor also will be very, very close. Let me quickly run through. Well, I think that's all. I have some slides on DC and AC motors. You can look at it. Yes.
Good morning, sir.
Yes.
So the answer of second is BLDC, and the answer of first is AC and fan.
Yes. 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 Thank you. Yes. Thank you. Can we replace induction motor with a brushless DC motor as it requires additional circuitry? Now, in the days when we are talking about integrated circuits, why are we worried about additional circuitry? It will be all in a single integrated circuit. Sure, you can replace them. I think tomorrow BLDC motor and SR motor will be replace pretty much most of the induction motors. I don't know, very high power induction motors may still be required. I'm less familiar with that. But at least low power, everything will be replaced. Right? Let me very quickly start with what I'm planning to do in lesson 3. I don't plan to do it in great detail today in the next class, but let me move to lesson 3. My colleague is going to do that next class, Dr. Prajot Kaur, on solar PV. I'm just going to introduce, we are going to talk about introduction to solar photovoltaics, characteristics, types and comparison, use of solar PV power without DC to AC converter, efficiencies and implementations. Essentially a solar PN junction, photovoltaic junction. I'm just going to run through some slides. I'm not going to go into details. And next class we'll repeat this. So for the solar cells, one of the most common important thing is I versus V characteristics. Both I versus V characteristics or power versus voltage characteristics. And the terms like short circuit current and open circuit voltages. We'll talk about that in the next class in detail. Effect of temperature on the short circuit current. And we'll talk about modules, how modules are made with cells, and how module operating temperature becomes higher than the ambient temperature, what happens, and what happens when it is lower. And we'll introduce the concept of maximum power point. We will talk about one of the most important things. This is what I will do. India is endowed with vast solar energy potential. You know, it is about 5,000 trillion kilowatt hour per year energy incident. 5,000 trillion energy is incident over India's landmass. And this is distributed throughout the country. Most parts receive 4 to 7 kilowatt hour per square meter. So every square meter, 4 to 7 kilowatt hour of power per day. That is what you get, 4 to 7 kilowatt hour. Solar energy most secure of all sources and distributed. Anything happens, any destruction takes place, bomb takes place, hopefully sun will be there in the morning and will bring sunlight and therefore will bring power. So extremely, extremely powerful source of energy. I believe tomorrow 50% of energy should come from solar. There is a term used, solar cell efficiency. This solar cell efficiency term is sometimes misused and not understood. So today I'm going to spend a little time on it. It is a percentage of incident solar energy that is converted into electric. Remember, a certain amount of energy is incident, and when that energy is incident, what percentage gets converted? That's all. It doesn't tell anything else. How much solar energy is captured from the sun in 1 square meter, in one area? You can of course take larger area and capture more power. So go back to the slides. For example, if it's 16.5% efficiency, what does it mean? That it will take 6 square meters. 6 into 16.5 is about 100. Is exactly 100. No, 99. 6 square meter to capture the amount of energy that would be incident on 1 square meter. So if it was 100% efficiency, you could capture in 1 square meter area solar panel as much energy as the sun gives. But now you'll require larger area, 6 square meters. But 6 square meters of panels, if you use, you will capture as much energy as falls onto 1 square meter. So for 5,000 watt hour energy incident per square meter, if it is a 5 kilowatt hour energy incident per square kilometer, it will require 6 square meter to capture 5 kilowatt hour a day. If you had 20% solar efficiency, you will not need 6 square meter but only need 5 square meter. So if I compare between 16.5 and 20%, what does it mean? I need a little more area. Or if the area is available, for example, if I'm using on my rooftop, that I use 5 square meter or 6 square meter will make a difference, but may not make all that much difference. So if 6 square meter is available, there is no particular reason to go for 20%. Efficiency only affects the land area used and does not tell what a solar panel will produce. When you buy a solar panel of 1 kilowatt hour, it will be of different size. But that 1 kilowatt hour will produce 1 kilowatt hour with certain incident energy. A solar panel is purchased based on certain peak wattage or peak kilowatt, and it really doesn't matter. So therefore, the more important thing to question is to ask that for a certain watt or certain kilowatt of solar panel, what is the cost? Efficiency only sort of say it will be bigger or smaller, but your manufacturer will give you bigger. As long as you have bigger area, don't worry about it too much. When one obtains a solar panel, one buys it in terms of watt. For example, a 125 watt hour panel will always give you 125 watt will be produced, assuming 1000 watt per square centimeter. So it is assumed that per meter, 1000 watt per square meter is what is assumed will fall during peak on, this is the more or less the peak that falls in around noon on a sunny day. 1000 watt. We'll assume 1000 watt falls. Of course, if less falls, less power will be produced. Assuming 1000 watt, 125 watt will be produced at 25 degrees centigrade. Now, this is important. If the temperature changes, that may not produce 125 watt. It may produce less. Dr. Prajot will talk about it next class. If it will produce 125 watt hour solar energy per hour, assuming 1000 watt, that is one sun, 1000 watt per square meter is also called one sun, is a solar incident during that hour, say between 12 p.m. to 1 p.m. Efficiency of cell does not matter here because the size of the panel will be such that only it will capture, if there is 1000 watt per square meter, if it was between 12 to 1 on a sunny day, it will produce 125 watt hour. So that is the important thing. If you buy instead of 125 watt hour panel, you buy a 1 kilowatt hour panel, it will produce 1 kilowatt hour if during between 12 to 1 when it's 1000 watt of sun is incident, it's a sunny day and all that. If it is not sunny day, if it is a less than a sunny day, it is slightly cloudy day, you won't produce that much power. Similarly, at 8 a.m. in the morning, 7 a.m. in the morning, you'll produce much less power. 8 a.m. you'll produce a little more, 9 a.m. you'll produce. The amount of solar incidence will keep on changing. At 1000 watt solar incident, it will produce 1 kilowatt or 125 watt. Remember, the other important thing is solar power produces DC. Actual power produced at any time will, of course, therefore depend on actual solar incidence at the time and the angle at which solar is incident. The solar must be incident, that much incident vertically. If it is incident at an angle, then all the power may not be captured. We'll talk about it. Temperature of the panel will play an important role. Temperature of the panel plays an important role because depending on the temperature, the power captured may be less or more. That's a characteristic of solar panel. And the circuit used, which is very important. Is the power drawn at a maximum power point? You don't use the right circuit, don't capture at maximum power point, you will not capture the right power. This whole thing along with the circuit for the solar cell, the characteristics, how to build modules will be explained by Dr. Prajot Kaur. I will end by sort of saying that today a watt of solar panel, the cost international market for very, very large volume has gone down to almost 27 cents per watt. That means that you pay 27 cents, which is, since a dollar is 70 rupees, 27 cents will be about 20 paise. About 20 paise. Is that correct? Huh? Will about 20 rupees. 20 rupees. So 20 rupees, if you buy a solar panel, it will give you 1 watt throughout its life for the next 25 years, depending on the amount of sunlight, depending on the temperature, and depending on how are you using maximum power point or not. Typically, you will get from that 1500 in India, 1500 watts per year. From 1 watt of solar panel, you will typically get 1500 from 1 watt of solar panel in India. Typically, you can get anywhere from 1400 watt to 1700 watt per day. This is based on what the sun, kind of sun that is available in India. 14 per, huh? Per year, not per day, per year. That is the amount of power that will be there per year from 1 watt of solar panel in India typically. Of course, this is assuming that you are keeping fixed. If you make it tracking, if you track the sun, you can produce as high as 1800 to 2000 to 2100. So you will get about 10 to 15% more, but then you'll have to keep on tracking and you'll require the motors and things like that. But if you keep it fixed and put it properly, you can get 1400 to 1700. I'll say 1500 and 1600 watt is very common. In Rajasthan, you may get as 1700. This much of DC power will be produced. This is taking into account all the temperatures. But circuit DC to AC conversion will be important, and maximum power point operation will be important. If you don't do that, you lose power. So the solar efficiency does not matter here. What matters is therefore the circuit efficiency and the DC to AC conversion efficiency. We very often are stuck on solar power, and this cost about 20 rupees, as I pointed out, rupees 20 today at very large volume, and this will be produced for 25 years. So 25 into 1.4 kilowatt, you can produce approximately 35 watt hour. This is 2400 watt hour. So 1400 watt hour. So in 25 years, you can do about 35 kilowatt hour, which is the unit of electricity. Each unit of electricity is in India typically costs 5 rupees. So 5 into 35 is 175 rupees. You spend 20 rupees. Of course, this is in very high volume, and you can get 175 rupees of electricity for the life. 20 rupees, you get 175 rupees worth of grid electricity today. This is of course only in DC form. If you lose to DC to AC, it's your losses. If you lose due to not running on maximum power point, it is your losses. If you do it right, you are from 20 rupees, you are going to produce 175 rupees worth of power at today's cost. So this is the interesting thing that we have to really understand. And this cost has been falling down. It used to be 60-70 rupees till recently. Well, even that was not bad. 60-70 rupees, you will be able to produce 175 rupees worth of power. It used to be 100 rupees. Then, whether it was worth it, 100 rupees you put in today, 175 rupees you will get in 25 years. But here, 20 rupees you put in, you will get 175 rupees in 25 years. Of course, those of you who understand a little bit of economics, or know a little bit of Excel, have to calculate that I'm not spending getting 175 rupees worth of good today, but over the next 25 years. So you have to take the interest into account and all that. But even then, it's extremely good, and the prices are further falling. Will it become 15 rupees? Very high chance. Will it become 10 rupees? Well, tough, but I would be surprised if it happens, but can happen. I think that is what we are talking about. This is what sun is giving us. On our rooftop, efficiency does not matter. In fact, today this is done with 17% efficiency. Today it is done with 17% efficiency, solar cells. If I try to use solar cells of higher efficiency, then the cost is not 20 rupees. Cost is much more. If I use 20% efficiency, cost is more like 40 rupees. But from that 40 rupees also you will get only 175 rupees worth of electricity in 25 years. Your, of course, area will go down from 6 square meter to 5 square meter. Is it worth it? Not worth it. So don't talk about solar efficiency, talk about the rest of the efficiency, which essentially from DC to AC conversion, maximum power point, how do you connect it and do this. This is what is important. And this is, I'm taking you away from the people who talk about device, only talk about 16-17% efficiency. It doesn't matter. Rest of the power is not lost. There in the, today all the power falls on the earth. All the plants and all of us live because of that solar energy. If it doesn't capture 100%, so what? 70% is good enough. The key thing is, at what price does it cost? Do it. Today it does it at 20 rupees and gives us electricity roughly about 175 rupees worth over the next 25 years throughout the country. This is the power, and in the next lecture Dr. Prajot Kaur will begin and talk about this solar photovoltaics and batteries. Thank you. Thank you. I'll stop here and I answer questions. Lectures are over today's and we will answer questions. Yeah, there are some questions that is typed. How can we improve distortion factor? Will it be possible to build all-weather solar cells? Well, if sun is not there, how will it capture solar incidence? But even in a cloudy day, if sun is partially there, it captures that. Beyond that, it will require batteries, and we will talk about batteries. What are the basic constraints to the construction of DC microgrid? We'll talk about it. Can I use DC excitation for small rating of motor? Yes. Is this expensive? Not true. Today you can make if you make very high volumes, it is not true. If you make 1 unit, yes, it will be very true. Integrated circuits basically require that we all-weather solar station is also done. Induction completely question 1, 2 is done. What are the basic constraints related to DC? We will talk about later. Can I use DC excitation for smaller rating of motor? Is this expensive? I answered. How can we improve distortion? I think I've answered all the questions. And I've given you some general idea of what today's costs are. This, of course, costs are in very high volume. If you go and buy a single unit, it may cost double of this, or maybe even more. But I think soon the prices will try to bring it down to this level. Thank you very much. I think nobody is. In China, there is an invention going on generation of electricity by modifying using solar graphene layer. But these are various things that are done on solar cell to increase the efficiency from 17% to 20% to 24%. There are lab solutions which are as high as 44%. But they're extremely expensive. You try to buy those kind of solar cell, instead of 20 rupees per watt, it will cost you 1000 rupees per watt. So no meaning. Let it come down. The Satpal wants to ask questions. Please connect them. Yes, please ask questions.
So in Murthal, if you install a solar plant, the temperature is about, maximum temperature is about 45 or 48 degrees Celsius. If you install the same plant in Rajasthan, there the temperature is more than 50, 55, will the efficiency of the plant will be same or efficiency will vary?
Well, Rajasthan, we have higher temperature but also higher solar insolation. Because of higher temperature, the output will go down. Because of higher solar incidence, output will go up. So frankly speaking, in Rajasthan, you will get a slightly higher power. So it will be closer to 1700 watt from 1 watt of solar panel in Rajasthan. It will be more like 1600 watt in western Uttar Pradesh. It will vary from place to place.
And so what about Ladakh area or in south like Kerala?
Ladakh area, from whatever I know, is also very good. I don't know how much cloudy it is. I am less familiar. That information is available. We'll try to give you a link that anywhere in the country from 1 watt, what is the average power produced, watt hour produced per year is known. It's available all through the whole country is mapped. It's available. We'll give you the link. You can also look at the search for it in Google. Amount of power produced from 1 watt of a solar panel. It will give you point to that place. It will tell you how much it will produce on the average in an average year. Okay? Okay?
Okay, sir. Thank you, sir.
Thank you. I think with that we'll wind up and see you in the next class. Next class, Dr. Prajot will start and then I will take over. Thank you very much.